So comparing fractions, but this time, look what we've got. Look what we've got. So let's get them on the board. Let's get them up on the screen, on this board here. So now it starts to get a little bit more complicated. It starts to get a little bit more tricky. Because now, what have we got? We go through that sequence of events, that same sequence of events, we have a look at what we've got. Oh, we've got an improper fraction, we've got a mixed number. We can't compare them because they're two different things totally. Right, so the first thing we have to do is make those the same. Do we make them as improper fractions? Do we make them as mixed numbers? Well, if we're comparing fractions, we need to make them both into fractions rather than mixed numbers. So we need to change this. We need to change that to a fraction. It's going to be an improper fraction. We know that because we've learned previously that we change a mixed number to a fraction, we get an improper fraction. So we're going to change that first. And we do that by getting mad. So m multiply the whole number by the bottom of the fraction. 1 times 7 is 7. Then we add. Do you remember? We added the top number. 7 plus 3 is 10. And then the denominator, we put the answer over the denominator, which is 7. Do you remember that last week? Changing it. So now what we've got an improper fraction, we've got an improper fraction. So not as to confuse ourselves, I'm just going to drop them down a little bit. There we go. 5 over 4, 10 over 7. They're both fractions. They're both fractions. Yes, they are improper fractions, but they're still fractions. So now we just follow the same procedure as we've just done before. We have to find a common denominator at the bottom from 4s and 7s. If we don't know that, what we do our 4 times table down here. We do our 7 times table here. We're looking for a number that's in both times tables. 7, 14, 21. There it is. It's 28. It's 28. It's in the 4 times table, it's in the 7. So we know that we can now make both those bottom numbers into a 28. So now we've sussed that, now we know that, we go to this fraction first, 5 over 4. Let's convert it. Let's do what we need to do. Remember, we're going to make the bottom into a 28. So we're going to times it by 1, 2, 3, 4, 5, 6, 7. 4 times 7 is 28. We remember the little mantra. Whatever we do to the bottom, we've got to do to the top. 5 times 7 is 35. If you're not sure about that, just extend your 7 times 2. Right, that one's done. Forget it. Let's go to this one. 7. How am I going to make it into a 28? 1, 2, 3, 4. I'm going to times it by 4. There it is. Whatever I've done to the bottom, I'm going to do to the top. 10 times 4 is 40. Job done. Yeah, job done. Back to the original question. The original question says which is bigger? Is it 5 over 4 or is it 1 3/7? It's this one. 40 over 28. Which was this one. Which was originally this one. So 1 3/7 is the bigger of those two. Does that make sense? Yeah? If you know this skill, if you can learn this skill, then when you come to adding and subtracting fractions, whether it's a fraction, whether it's a mixed number, whether it's a whole number, as long as you can recognise it and start to be able to change them round, you shouldn't have any problem. Okay? They're not easy. Be a liar if you said they were. And there's a lot going on. There's a lot of numbers on that page. A lot of numbers for such a small sum. that's what confuses people. That's what makes these tricky. Does that make sense to everybody though? Yeah?
Do you know, if you didn't do all of that working out, would you have known 137 was the biggest anyway, because it had that one hole?
Yeah, you could just guess. You could just guess. But that would have a whole number, wouldn't it? That'd be 1 1/4.
If
Yeah.
you doesn't see it, wouldn't know, would you? That would have been a 5 out of 4
No,
parts.
but you recognise it, don't you? You recognise that that's 1 1/4. Yeah, you could guess. In the exam, you could guess, take a guess. Yeah, that's the right answer. But the examiner's going to say, where did you get that from?
You need to show you working.
Where did that number come from? How do you prove to me that that's the biggest number? So, let's do a little tester. I think it's in the bottom, the last page of that work page we've just done. It's Mike and Sally. So here's Mike. Mike's run 6 8/10 of the track, and he says, I've run further than you. But Sally says, I've run 144 out of 25 laps, and she's run further than him. Who's correct? Who's correct? Similar to what we've just done. Similar to what we've just done.
Yeah.
Have a go at that one. That's a tricky one. Have a go at that one.